All right, now it took me a second to round them up, but these are our Fanuc specialists that are going to help us out. This is Erwin and this is John. Now John, one of the main questions that I have for you, is it called Fanuc or Fanuc?
In the United States, it's commonly referred to as Fanuc. Fanuc is an acronym which stands for Fujitsu Automatic Numerical Controls. Like the United States, Japan has different dialects between northern and southern Japan. Many people in Japan will refer to it as Fanuc. In the U.S., it will be referred to as Fanuc.
I'm going to call it Fanuc.
Yeah, I'm going to call it Fanuc.
Now, do we only have the ability to test the Alpha series drives?
Jennifer, with the 16 series control and 150 series control, we can test any of the Alpha series drives.
And with our other test stations, we have the ability to test the Beta series as well as the older S series drives.
Now, Erwin, what is the proper way to test a motor for a short?
The proper way to test a motor is to first lock out the machine, remove the cable from the drive, and test all 3 motor phases to ground with a mega ohm meter. This way you will test both the motor and the cable for problems.
Now, John, I have a customer of mine that's trying to communicate with his machine using an RS-232 port, and he keeps getting errors.
There are several things that can cause these errors. The RS-232 port is a high fail item on the machine tool. It's very susceptible to electrical surges. However, one of the most common fail items is the cable. You need to make sure that you're using a known good cable when communicating. Otherwise, when you attempt to either read in or punch out a cable, a signal, you'll get a 086 alarm that's going to indicate that either the cable is incorrect or the port has failed. Take a known good cable, insert it into the RS-232 port. Set your machine up to receive a file. In this case, we will read in a file. The screen will begin to flash read. You will now transmit your file into the machine tool. If the screen continues to flash read, or on the more modern controls LSK, but never receives the file, you either have a break in your cable, or more than likely a defective COM port on either the memory board or master board. These will need to be sent in for repair.
Now, John, one of the questions that I hear a lot is, why does the spindle come to a slow stop?
Spindle drives make use of what's known as a regeneration circuit. The back EMF of the motor is regenerated back into the incoming power supply. This brings the motor to a controlled stop. If there is a failure in the regeneration circuit, the spindle will coast to a stop. This problem is usually indicated on the spindle drive as a failure in the regeneration circuit. However, regeneration is the responsibility of the power supply unit. So look to the power supply as the cause of this problem.
Now, another question is, what is an access communications error?
An access communication error indicates a communications problem between the motor encoder and the CNC control. This can be caused by the motor encoder itself, the cable going to the encoder, or the access control card that is plugged into.
Okay, now John, what is an excess error alarm and what causes it?
Excess errors can be caused by a variety of problems. An excess error means that the machine has moved beyond its allowable tolerance. The CNC has told the servo drive to make a move. The servo drive moves the motor, which in turn moves the encoder or scale. There's no such thing as a perfect machine. As the machine is moving, it's going to have some deviation. This deviation is known as the excess. Parameters are configured in the machine that tell the machine how much deviation you're allowed to have. While stopped, you'll have a very small amount of deviation. While moving, you'll have a larger amount of deviation. Deviation errors can be caused by a variety of things. A dull tool can cause the axis to be pushed out of position, resulting in a deviation error. Excessive chip buildup underneath the way covers can cause the machine axis to be pushed out of position. This will cause a deviation error while stopped. Servo drives failing can also cause a deviation error.
Now, a lot of times my customers ask me about specific alarms. For instance, the 401.
The 401 alarm is a very generic alarm. It simply means that the servos did not obey. The CNC, who is in charge of the servos, tells the servo drive to turn on and stay on. If for any reason the servo drive turns itself off without permission from the CNC will generate a 401 alarm. This alarm will typically occur with other alarms, such as the 414 alarm.
Now, that was my next question. What does that alarm mean?
The 414 alarm is an alarm issued by the CNC that says a problem has been found in either the servo drive or feedback system. The 414 alarm will show which axis is causing the problem. To identify the specifics of this alarm, you will go into the CNC diagnostics page. Diagnostic number 200 on the 16th row will indicate what is causing the problem. In this particular case, diagnostic 200 x-axis shows a low voltage alarm occurring. This would indicate a failure on the servo drive system or power supply. It could also indicate a failure with the three-phase power coming into the servo drive. In this series of alarms, we have a 400, 401, and 414. The 401 alarm indicates a generic alarm that says something has occurred in the servo system. The 414 says that we can go to the diagnostic 200 to see the specifics. The 400 indicates that an overload has occurred. This indicates an overtemperature in either the servo drive or the motor itself. When we access diagnostic 200, it will show that there is a low voltage and an overload that is occurring in the x-axis. Diagnostic 201, bit 0, specifies whether or not this is a problem in the servo drive or the motor.